Welcome back. We're in Vectors and Projectiles, worksheet number 1, problem number 3 out of G and Coley here. 3 vectors are shown in the diagram below, right there. Their magnitudes are given in arbitrary units. Man, this sure seems like a math problem, and it really is. Determine the sum of the 3 vectors. We say that because it's there's no physical example, and usually physics is like very physical examples. Well, the guy I guess doesn't have to be physical, but real world examples nonetheless. Anyways, we're getting up to that, and that's why we need to look at vectors. Give the resultant vector, which is the total vector, you might say, or the solution, in terms of its components and the magnitude and the angle with the x-axis. Okay, so reasonable things it's asking for. Now I look at these 3 vectors, and I can remember I can move these wherever I want, and in this case, moving them doesn't seem to. I don't think it's going to help too much. So I'm going to leave it the way it is. Furthermore, I also think about my coordinate plane here, and they listed one, the Cartesian coordinate plane. It looks like the x direction here and the y direction over here. And remember that the coordinate plane is something that we are arbitrarily using. It's a construct of the human mind here. We can change that however we want as well. And so I think about rotating the coordinate plane. Like I could rotate it so it lines up with one of these things or lines up with another one. And notice that C already lines up perfectly with 1. So, and I can't rotate the coordinate plane to line up with 2 of them that I know of. It sure doesn't look like it, and I look at the angles here, and clearly I can't. So I'm going to leave it the way it is. Now, if C was off like here instead, I would go and rotate the coordinate plane so it lines up at least with C or A or B, just at least one of them, and save me a little bit of work. Because I won't need to do component vectors for C. It's only going in one direction. Okay, so right off the bat, C doesn't have component vectors because it's going in only one direction. B, let's look at B. B does have component vectors because it's going in 2 directions. Which direction is B going in? You could say it's going like up and to the left, a lot of people would say. And I'd say, okay, cool, yeah, sure, it's going up and to the left. And I'm going to redraw that because I don't like how it doesn't actually like match up with that. I'm sorry. That looks much better. And notice how the arrow tip there is right on the tail of the other one there. It doesn't extend beyond that. Sometimes I see people doing that improperly there. Now B has arbitrary units, and we're measuring the angle there. So this is the adjacent side. So this is 40 cosine of 56 degrees. And then this one is going to be 40 sine of 56 degrees. Great. And that's pretty easy and straightforward. Let's go to this other one here. A is going up and to the right, which means that A is going in 2 dimensions there. So let's go ahead and let's break that down into how much in the x direction, how much in the y direction. And again, 28 is right there, so it's going to be 66 times the cosine of 28 degrees. And this is going to be 66 times the sine of 28 degrees, if I can write an 8. There we go. And so why did we do this? Well, this is going to be a lot easier because now, let's check this out. I have 3 in the x dimension here, and let me label those in fuchsia. I have in the y dimension, I have 3. In the y dimension, I have this guy, and this guy, and this guy in the y dimension, and I'm going to add those up in the y dimension. And then I have 2 in the x dimension. We'll do that in black here. I got this one and this one in the x dimension. I'll add those up, and so then I'll get a total in the x dimension and a total in the y dimension, and then I'll be able to use those totals to figure out the actual total. This seems like a lot of totals, but there's subtotals kind of. And maybe I should have said the Vx total and the Vy total, and then we'll get the actual total. That's still a lot of totals. Anyways, let's go ahead and let's do one at a time. We'll do Vx first for no reason at all. And when I go and do that, I see that I have 66, that's going to be the positive one, cosine of 28 degrees. It's positive because it's going to the right, as you normally suspect. I'm going to add that to the other one, which is 40 cosine of 56 degrees. And yeah, that one's going to the left, so I need to put a negative sign on that to give it its direction. Remember, it has to have a direction there. And if I can go and do that, I could leave it like that if I wanted to. But I'll just go ahead and punch into my calculator, and you are as well. And make sure that you're in degrees there, and make sure you get that negative sign in there as well. And when you go and do that, you get 35.91. And we don't have units. Man, it's so weird. I'm like trying to like put units on that because if I write down a final answer for anything, or even a sub-final answer, subtotal, I'm always going, oh, what are the units on that? And you should too. Okay, now we'll do that in the y dimension there. So notice that that's a positive value, so it's actually pointing to the right. That makes sense because this looks like the diagram is drawn probably to scale there, and it sure looks like the right is way bigger than the left, and the math shows that to be true. Now I'm going to add up the vertical bits, and I have two vertical ones that are positive, this red one and the green one, and then one that's negative, that's C right there. So I'm going to start with the positives. 40 sine 56. Sine 56 degrees, and this is addition and subtraction, so the order doesn't actually matter, 66 sine 28. But a lot of times people like putting the positive ones first, and I add that to 46.8 going down, 46.8. I immediately just put a subtraction sign. Clearly you could put a, add them together and label this as negative. Mathematically it's the exact same thing, so it doesn't actually matter. But let's go ahead and let's get a numerical answer for this. So 40 sine 56, you're punching into your calculator too, 60 sine 28, and then minus 46.8, and I get 17.35. And there's no units. Man, I really wanted to write down units again. Okay, so now here's where I would sketch this again. So I'm going to go ahead and I'm going to put down Vx. Vx is going to the right there, and 35.91, because it helps me visualize what's going on. And Vy is going upwards there. Oh, I should have written this differently here. Let me move that around here. I'm still getting used to this pen here. So, I don't want to change the size of that. I want to move where that is. Thank you. And then Vy is positive, so I'm going to put it at the end of that one and say it's going upwards there, 17.35, because we want to find the resultant vector, and if you put them tip to tail like that, then it's easy to draw the resultant vector, right? That one's going to the right and upwards, and so then here's my resultant vector that is going up and to the right, the same, general directions there. We don't know what angle, that was part of the question there, we don't know what angle, so let's find that first, because we've got to do something first, and it doesn't matter which one we do. We know that V is going to be equal to the square root of the squares added together, so that's going to be Vx squared plus Vy squared. And we have those numbers right there. I stored them into my calculator as letters. You can do that in the bottom left-hand corner of your calculator if you have a TI. There's that STO button, so you can have a number there, press that, and then store it as any of the letters. You punch in whatever letter you want, and then you can just use that letter later on. So I did Vx, since I did that first, I had stored that as A, and so I'm going to do the square root of A, and then I square it, and then plus, when I did Vy, I stored that as B, and so then I do B squared, and then boom, it just gives me the answer. It's like so much more efficient. And it's 39.88, and there's no units. Oh, gosh, I tried to do it again. And then what angle is that at? Well, now I can just use sine, cosine, or tangent to find that angle. It doesn't matter which one it is. I'm going to go ahead and use tangent this time because, I don't know, I just keep using different ones every time. In case you catch one and you like that, and then you can do that one, but it doesn't matter because we have them all, and they'll all come out to be the exact same thing. So opposite over adjacent there, I need to do inverse tangent, so I'm going to do inverse tangent of that stuff right in there. That just means the same exact stuff. So I already saved the 17.35 as B in my calculator and the 35.91 as A in my calculator. So I'm just going to do inverse tangent of B over A, the 17.35 over 35.91. And when I go and do that, I get 25.79 degrees. Don't forget degrees. We do have units on that, even though everything else we don't have units on. And that is part of my answer. I go back and reread the question because I think we're done here. And boom, we gave the results in terms of components. We did that. Magnitude and angle with that, we did that as well. Boom. We are done. That is it. Have a beautiful day. Thanks. Bye.